Hello and good morning. Let's see. I'm super happy about something. I played around with. Let's see. Let me remove this. Let me remove. Oh, it's my face in the way. Let's see. Let's just do. Oh, there's my Slack. Can I flip this around? No. Anyways, let's just do this. Cool. So, what I did was I've been thinking about like would you express a state machine for classes. That has been like super tricky for me to figure out. But going through our sessions with our application and developing the API for Overmind, it's suddenly this morning I was just waiting for my daughter to finish watching her morning children's show, and I kind of coded this thing together, and it just clicked like, yes, this is exactly how it should work. So let me show you. I have some code here. So this is not related to Overmind. This is related to this other project, and we'll see if we will get to that shortly. But the point is that it's really tricky to have this dynamic typing of the state, and then thinking about base state and how do you deal with messages and all this stuff. But I actually found a really nice way to do this. So you still type your state like current foo, or current bar, for example. And then you might have some event type do something or something happened and like that. I'm not sure why it's complaining. Why? Oh yeah, let's call it events. And now when you want to define a state machine as a class, you would do class, maybe we can do some machine. And then you extend a state machine and you give it the state and the events as types. And now when the only thing you need to do is that you need to implement the onMessage handler. So onMessage receives a message which is of or like an event. Yeah, maybe it shouldn't be called events. It should be called like event or something. No matter, you implement that, and the expected return type here is state or nothing. So if you were to type this wrong, so if I were to type this as string, for example, it starts yelling because it has an expected type here. Like you need to implement this, right? Okay, so let's just call this T event and T state, just to be perfectly clear here. And then T event, and we're going to finish this implementation, by the way. So we'll call this S and this E. Sorry, I could have done this more quickly, but anyway, it's E, and then T event, and then T state. Okay, cool. So what we have now is this machine that needs to be in either foo or bar, and then we have this onMessage handler. So when we create a new instance of this, some machine, it already knows that you need to pass it the initial state. So for example here, I can say current foo. But if we were to, for example, pass is awesome boolean to bar, and we would instantiate with bar, it would yell at you and say you need is awesome, right? And this is exactly what we want. And then, so that's part of the instantiation. Now, if I wanted to, should I go into this now? Okay, let's go into that now. So we're talking about state here, right? So what if you wanted some base state? And base state means state that is always available. Now in Overmind, that's a little bit tricky to do because you have the Like the state is the state. The state machine state is everything you have to deal with. But here we can actually use the instance properties as the state. So to make that more clear, if I point to test, I actually point to state, and then I have the current state, right? So I can say if state current equals bar, then test state I have is awesome there, okay? So if I wanted to instantiate with some base state here, what I could do is I could create my own constructor, and then the first argument needs to be this t state, and then I could have like is awesome, or no, this is something else like blah, which should be a string, and then I say super state. So now it gets its state, and then I say this blah equals blah, and then blah is a string. And then when I instantiate this, I need to pass a string here. And when I now point to test, blah is always there. It's instance properties, while the state is dynamic depending on like what's the current state of the machine. So that's really, really cool. So that's handled, and then let's remove this. Oops. And then we have, yeah, maybe I can blow this up a little bit. There we go. Yes, so that is the state itself. And then we can talk about like how would you do, so in a component you would do like if test state current is foo. That's perfectly fine. But in actions, in logic, the way we dealt with this in Overmind is that you had this matches API. And the really cool thing here is that when we have separated instances, like instance properties from this state property, we are able to do this. So in some action, I can say this matches foo, or let's say bar, bar. And what it gives me is the actual state object. Instead, it doesn't give me the instance, it gives me the state object. So the matches API is related to if the state is there, or if the state is bar, then I will give you the state object so that you can continue diving into it, right? This makes perfect sense, because if you had like a base state, it would just be on the instance itself, so you didn't have to match. You could just point to it directly. So it makes perfect sense. I really like that. And then what we did is that we had this event. So by just giving this event, you can say test send, and then you have the event. So type needs to be, as you can see here, something happened. That's the only thing we have. And again, if you had different events here, you would pass them in with different properties. And then we can, in our machine, we are going to deal with these events. So we are going to say, we could say here, if this state current equals foo, for example, then we want to, so let's say if event, let's sorry, switch event.type. So if the event type is something happened, break, not sure if it might else here. Oh, sorry, case. So if the event type is something happen, I could call like a private method here if I wanted to do that. But I'm not going to do that. I'm going to rather return a new state. And now I actually have to type this. So if I say current foo, then that's perfectly okay. But if I move into bar, it tells me that I need this state to make that state valid, which is exactly what we want. And again, I can just point to this blah and push something here if I want to do that. I can even point to this state to do's and push a to do if I want to do that. And that's also what we want. We don't want to tie ourselves to this immutable way of expressing things. We just want to manage the events coming in. Are we in the correct state to manage that event? So what you would typically do here to guard it is to say if state, this state of current equals foo, that's when I actually want to deal with this, right? Oh, so you have the exact same way of guarding everything. So yeah, this is, for me, this is perfect. And I'll show you how this ties into my little side project very soon. One thing that this doesn't handle quite yet is disposing. So we are going to create a disposer here. And all the machines needs a disposer. And basically what it's going to do is to go through the state for each. And then the key. Well, I guess we can say like for let, how is this, x in this dot state. Sorry, x, oh, I shouldn't, for key in this state. It isn't in, it gives you the, yeah, key of s. Yeah, so it's the string. And then we can check if this dot state key instance of state machine. Then we want to say this dot state key dispose. So we have this nested disposing. Why doesn't it understand that? Oh, is it? What do I get here? Do I get, when I do in, I find this very confusing. In, or do I actually get the value? Let value, if value instance, is this how I do it? No. Extract key of, god damn it. JS for in. What do I actually get with a for in loop? I get the property. Yeah, so what is it complaining about? For key in this state. Doesn't it understand? Oh, I guess. Cons value. Is it because of this? Yeah, I find that strange. Why it isn't. I guess it's because it's a dynamic key or something. TypeScript isn't able to infer that when I point to this, it's able to identify its type because I do instance of. So I kind of have to make it value first. It's kind of funny. Anyways, so this is what we want to do. When this state machine is disposed, it should go through its state and it should dispose everything there. Yeah, I guess there's one thing I haven't thought of here, and that is if you were to insert a state machine as, yeah, but that's the point. That's the point. I'll show you. I'll show you. Yeah, on the class instance. Yeah, but I think that's something you should do manually, and I'll show you why and how you would express it. So, what were we doing here? Yeah, so the point is, when we do this, when we move into a new state, we're going to say this dispose. Because we want to, whenever we replace the state, we move into a new transition state. If we have chosen to bind a nested state machine to a specific state of the parent machine, then we want to dispose of it when we replace that state. So that's what this logic deals with, right? So what if you had like a attached property, like you have a base state that's a nested machine? So let's create a couple of machines. Class machine A, extend state machine. And let's just do something very simple. It only has one state and it only has one event type, something like that. And then we have machine B. It has the same state. And then we say that, okay, this thing here, foo, or B equals new machine B. Can I do that? Oh yeah, sorry. Current foo. Now the thing is, if this machine A was being disposed, and you have chosen to have a class property here, what you want to do is you want to override this dispose. Oh, sorry. What's it called? Super dispose. And you say this be dispose. That's what I mean. So you are responsible for doing that. And you could say that's something that should happen automatically, but I don't think so. I don't have a way to articulate it. It's more of a gut feeling. And it's basically because this is so clean. This is what the state machine does for you. It handles this state property. That's what it does. Whatever you choose to put on like everything else is up to you. Whatever you put on this instance, that's yours, and you deal with that. And then the state machine deals with this state property. That's its scope. Okay? So I guess that's the argument. But yeah, this is pretty cool. But now let's move into my little side project. I'm going to show you something pretty awesome. Let's see, how do we do this? We need to go into insiders, and we need to find my project. Maybe I have it there. Yeah, reactive app, nice. Okay, I guess my face is in the way again. Let's see, where's my terminal? Pull. Okay, my face is in a good place. Oh. Okay, so I'm going to show you the concept here first, and then we are going to npm run extension watch. Where are we? And then we're also going to run. Oh, I think I need to install first. Npm run extension dev. And then we are going to open a project here. Let's see, maybe I can prepare a project somewhere. Oh, maybe I already have one. No, this was something else. Okay, so reactive app demo. Dem, that's okay. Yeah, but then why does it auto displace menu? Oh, it's because you don't have any. Yeah, where did I? Oh, yeah. So why don't you do the disposal of the transition? It's because like this transition is hidden from you. You don't explicitly change the state. The only way you change the state is by sending events. And then, oh yeah, so you mean like, why don't you go, oh, sorry, do we have something here? So if you were to do like on message here, blah, event is, okay, type, I have to do this a little bit more explicit, and then it's current foo or void. So if you were here and you would switch on the event, event type, and you would say case is foo, and then, oh, good thing we didn't remove the code. I wonder how that happened. Case foo, and then you would kind of say if state.current equals foo. So this is the event type, and this is this, yeah, sorry. Oh, camera in the way, thank you. If this state current foo, you would say like, okay, this state some machine state.dispose. Yeah, you could say that you would manually do that as well. But still, I'm thinking that this state is something that the machine deals with. So I guess the argument stays is that where the machine has its responsibility is this state object. That's what it deals with. That's what it helps you with. It takes events in to deal with this state object. And yeah. Because you could also want to keep the machine alive from one state to another. Yeah, that's true. I would, so that's like, I don't know if it could be called an edge case. I don't have enough experience using these machines to say what's an edge case, but so you have like 3 different transition states, and in 2 of them, you want a specific machine to be active. Then you wouldn't want this machine to automatically dispose of the machine, because you're moving to a new state where that machine should still exist, right? Yeah, maybe. Yeah, like it's a valid argument for sure. Yeah, it's just what I'm thinking is sometimes you yeah, I don't know. I guess that's something that needs to be explored. I just really like the concept. Like, so the reason it even pops up is because this happens automatically in other state machine solutions, that they dispose of themselves when the parent doesn't look at it anymore. So I guess my argument would be like, okay, if you have 2 different states that needs access to the same machine, then you would make it an instance. And then you would rather manually deal with that instance. Like, that's better. Like, I would say primarily you want to clean up the state machine when it's part of a specific transition state. And if you want to share that machine, like, at least from my experience, which is very limited, you typically don't want the machine to be available for specific states. Either you want it to be available for all states or one specific state. So what I mean to say is, like, if you want to share it between specific transition states, then you would rather do it here. So you would say like this be dispose. And then when you move into some state that should deal with it again, you would say this B equals new machine B again. So I would kind of flip it around. It would be the responsibility of the base state to deal with a machine sharing different transition states, but being disposed related to other ones. But yeah, this is not set in stone for sure. I haven't tested it yet, but I'll keep that in mind at the end. It's a good point. Anyways, I'm so excited to show you this thing, so let's get to it. Extension watch, and then extension dev, and then I believe we can just run the extension. And hopefully everything runs. It's not cat coding anymore. Oh, I have a test here already. Maybe we can just use that. Yeah, let's just use that. Let me just do not ask me again. Let's move this app. And there is this. What's this? No, let's open a new one. Let's see, open development temp reactive app demo. Okay, so what should happen now is that I should have what's it called? Reactive app. Why isn't it? God damn it. I did change it. No, why does it say cat coding? Did I forget to push? I always forget to push. Do I really have to go and grab my computer? Yeah, what the hell? Okay, just give me 1 minute. Let's see. I can't believe I forgot to. Oh. Commit. Push. Oh, yeah, I'm using the source control of VS Code, and I thought when I committed it would also push it, but it doesn't do that. Git pull. Okay, anyways, we have it now. Let's see. Now we have to npm install again. Npm run extension dev. We can kill this one. Okay. Yeah, let's see if we can start it now. Come on, parcel. Parcel. Oh my god. There we go. So let's run the, let's stop it and run the extension again. And now we should have start reactive app editor. Okay, and it says no project opened, and that's because, where's my terminal? That's because I haven't initialized anything here. Let's initialize it. Then we need to install React, React DOM, types, React types, React DOM, parcel bundler. It's parcel bundler, right? And then we also need MobX actually. I think that's it. Actually, I thought it was supposed to automatically update here. That's weird. I'm going to fix that. Okay, maybe we can create like a source folder here. Index tsx. And let's import from React. And we also need like an index file here. And this should hold like app. Oh. And then script is the index. Ugh. Auto completion. I hate it. And then we have like app, which is hello world. And then let's render out that app to document query selector. Maybe I should have prepared this. Sorry. And render comes from React DOM. Cool. Yes, and then let's create a script to start this thing, and that will be parcel index HTML. Cool. Yeah, now it says missing depths because I think currently I actually also require, for some reason, let's see, backend initializer. Where do I have? Yeah, MobX React Lite. Okay, let's install that as well then. Oh, how do I get back to my thing? Where are you? There you are. npm install MobX React Lite. That's not supposed to be that's not supposed to be a hard like a required dependency, because that's React specific. But let's see. There we go. Yeah, now it starts. So let's run the actual project here, and we'll do localhost 1234, and we'll do this. Let's see. Yeah, it needs to install TypeScript and all the things. Okay, cool. I don't remember if I did this on the stream. Like I showed you this IOC thing. I believe I did. But let's not talk about that now. Let's just, let me just show it to you. So I have my new application here now. And I have this editor called Reactive App. And I want to start to build up the state management and the business logic for this. So let's imagine I want to create... Okay, let's do a simple example. I want to create a to-do app. So what I do is I grab a class, I move it here, and I call it to-do. And now I have like an entity in my application, like in a visual space called to-do. And when I click that, I can go in and edit it. And that brings me to the file, and I can start populating it. And what we want to populate this with is like, okay, it needs a title. And that title should be observable. And this is actually supposed to come from, not from MobX, but from the runtime library of this thing. But it's not published to NPM, so we have to do a little trick here. Reactive app. We need to bring in this runtime library ourselves. TS and then devtool TS. Let's see, and I actually have to copy it over currently. How do I change the... That's so annoying. So this was the index file. And let's just make this smaller. There we go. And then we have devtool, and then we have common. Okay, so we have our actual app here now. So what we want to do, we want to import this from Reactive App. So this will be like a published NPM package. The point is, this wants to have a title, and that title should be like a string. And then when we create this thing, we actually give it a string, and then we say this title equals title. Cool. I'm not sure why this is complaining. Oh, yeah. We need a tsconfig JSON. What's it called? Compiler options, experimental decorators, true. There we go. Okay, so now we have our thing here. So if we move back to our reactive app, you can see that, okay, now it knows that a reactive part of this to do is the title. Cool. So we have to do now. And what happened under the hood here is that this app directory, it actually created the class for me, allow me to populate it, and it has this index file where it actually creates an IOC container and inserts everything. You don't have to think about that. What you think about is this visual representation of your app. Okay, so now we have like a to-do. So what we want to do now is to create a new class called, for example, to-dos. And to-dos wants to create to-dos. So what we can do is that we can drag a pointer down here. And now this to-dos has a singleton to-do connected to it by default, but we can change that into a factory. So now our to-dos is able to create instances of to-dos. So let's look at how this looks like. So it has automatically done everything for you. The only thing it hasn't done is that it calls it to do. We should do create to do. I'll fix that. Now the point is we can now create a method here and we can call it like an action. And then we'll say add to do. Maybe there's like a title for it here. And what this does is, let's just have a list of to-dos, list to do, something like that. So we can say this list push this create to do title. And as you can see, even though this is a factory, it knows based on the constructor arguments here what you need to pass into this factory function. So there's, I'm going a bit fast here, but there's tons of typing that's like done for you here. So now let's go back and see how it looks like. So now we have a to-do with a title, we have a to-dos thing, we have the ability to create to-dos, and we have the list and the add to-do action here. So let's actually start doing something with this. So in our source here, we have this app component. Oh, do I need to say, oh yeah, JSX is React. Shouldn't it be happy now? There it's happy. Cool. Yes, so now we have this thing. So let's import a container from our app. And let's go grab an instance of the to-dos. So container, we're going to grab a singleton, and we need to grab a singleton of to-dos. Like this is the entry point of our app, right? And now we actually have access to these to-dos. So let's do something here. Div, blah, and let's just do a simple form on submit. Okay, I have a feeling we're going to go way over time this time, but I'm like super excited for this thing, so let's just do it. Prevent default. And this is going to be an observer, and this is what we get from MobX React Lite. Anyways, we don't have to like pass the to-dos in or anything. We're just going to do it a bit bluntly right now. But oh yeah, oh come on, return. Sorry, I have to type this out. Title, set title equals React use state. We just have to give the input a value here. Title on change event set title event target value. There we go. And then when we submit, we're going to say to-dos, and it was supposed to be typed. Ah, shit, why isn't it typed? That's weird. Didn't I fix that? I thought I fixed that. Anyways, the get should be typed. Okay, so it doesn't really matter here. We can use get, that's perfectly okay, as long as we don't use it more times. Yeah, I have to fix the typing for get singleton. Anyways, we have our instance of our app, and we want to add like a to-do here. There we go. And then we do it like this. I'm not sure why this is so unhappy. Why are you so unhappy? Oh, there we go. Okay, so now the really cool thing is that now we have this static view of our whole application. And you can imagine this could be huge, like any effect you have created, any entities you created, any like classes that does stuff like the to-dos here that kind of binds it all together. You can imagine having this huge map of everything So when a new developer comes in, they can just open this and they can see how everything is connected in your app. And I love this because even though in Overmind DevTools you have really great insight into your app, you don't have this complete mental idea of how everything is connected. It's like you have your state tree there, you have some actions that executes, you don't know how all these things are connected. But here you do, which I think is insanely powerful. And you don't only have this mental image of how everything is connected. You can imagine like, well, first of all, you can move these things around. So you decide how this is going to be displayed. And all this stuff is stored in the app. But you can imagine like adding a new feature here. So you've been planning a new feature, you know what classes you need, and you kind of go in and you drop the new feature in here. The first thing you do is kind of drop it in, and then you start connecting what it needs. And then you find its place in the mental image. You kind of, maybe you have to move it around here. Maybe you need to move the to-do a little bit. And maybe you need to move some effects around to kind of more clearly see how everything is connected. And that's mind-blowing to me, because the way we do this typically is like, what should I name the file? Which folder should it be in? Like you think about this file structure to create a mental image of how the application works. But the application itself is not hierarchy. I can't express that word. Like we think about our app as this tree, but our apps aren't trees. They are like nodes of things being connected together. At least that's my experience. So I think this makes a ton of sense. Anyways, so now everything's running. We have our app here. So let's try to create a new to-do. Hello there. And we send this in now. And what we can see here is that our to-dos now has something in its list. It has an item. And when we look at that item, it even states that this is a to-do. And the instance ID is 2. What it also states is that our create to-do factory created an instance of a to-do with the ID 2. That's pretty cool, right? And then what I can do, I can, for example, in here, I can click this, and then it moves me to the class that actually created this instance, and I can take a closer look at it. And if I were to add something more here, hello there too, or bippity boo. What you'll see here is that now we suddenly have another to do here. So I can go to this class, this to-do class, and I can see all the instances that has been created of this class. But I can also go to to-dos and I can see what instances were specifically created by this class or this factory, right? And if I use these instances somewhere to like populate a list or something, I can even here see, oh yeah, this is actually this specific instance. So you can imagine to-do being connected to other classes as well. You would have a collective overview of all the instances here, and then the specific factories shows you where stuff is. And even if one class passes an instance to another class as like an argument to an action or something, you would even be able to see it there. So that's insanely powerful. And I'm super excited about that. Okay, so I guess I kind of shown you the gist of it. Yeah, and this is such a weird bug. I have no idea why this increases in size. But back to our state machine API. So as you can see here, we only have like a default class here. But what I want to do now is I want to add a second type of class here, which is our state machine class. So you can say that, okay, I'm going to implement a feature now. So for example, maybe you're going to implement a form. So a good way to implement a form is using a state machine, while, for example, implementing something else does not require a state machine. So the point is that you have these different kinds of blueprints for implementing different kinds of functionality. So let's see if we could do this quite quickly. Let's imagine, how would we do this? Client, components, flowchart. Oh, I'm calling a flowchart. Yes, and then we have current class. No, sorry, sidebar. This is the sidebar. The sidebar has, yes, here we go, class item. So let's create another class item, which is going to be type state machine. And this is the same thing. It kind of has, it's not different. It does kind of the same thing. Yeah, I don't think we need to do anything else here. Yeah, let's just try this. Okay, so we have this thing called a state machine now. And if we refresh, let's see if it pops up. And if we start getting into lots of errors here now, I'm going to stop the stream because I really should get to work. But let's see what happens. Wow, is it? Why is it so slow? Yeah, that's weird. What the hell happened now? It just broke. That's weird. What the hell? And my computer is going kind of crazy here. I'm not sure what happened. Oh, seems that I have to stop it. That's weird. Let's try to run it again. That's weird. No idea why it was so bad. Anyways, as you can see, now we have a state machine here, and we can create that. And when this state machine is created, let's see, I'm not sure if we're actually passing the type here. Let's on drag node stop class update. Yeah, we're not passing the type here. We need to pass the type. So we need to say type data type, and we need to, okay, it's quite a bit of work. But the point is, as you probably can imagine, is that when you drop this state machine, it won't just write a class like this. It will actually give you state, or like t state. It will give you t event, and then it will export class whatever the name of the file is, my form, and then it would use state machine t state t event from the reactive app, and then it will already have the on message for you, which says t event, which can return t state or void. That will be ready for you. Maybe we can even add a switch here. Oh yeah, t event, it doesn't know about, no, let's drop that. Anyways, the point is it prepares this stuff for you. Yes. And what we'll also do is that since the state, like the state of, that's what I meant, because when we create this state machine, its observable state is like hidden from the static analyzer. But since we are actually creating the state machine here, we can just add a property to it called state. So that's kind of hard coded. And whenever that state updates, it will push that information through the runtime to that to that thing in this, like that will just work. The point is that we can just hard code that. So it instantly shows you that you have an observable state property on this class, even though it's not defined here, which is pretty cool. Yes, that's pretty awesome. And that's what I kind of love about this, is it's such a different approach to doing things. But my biggest, like, I've never been like opposed to, oh, my zipper is open. I've never been opposed to object-oriented programming. I really like it because you co-locate your state with your, well, basically properties and methods. You put them together. What I've been opposed to is, like, my first experience with object-oriented programming was Java, before really understanding programming. But just looking at the insane inheritance stuff my colleagues did writing Java, my intuition was like, what the hell? Why are we doing all this inheritance stuff? There was so much inheritance that was unrelated to actually writing any logic. It was just creating this insane mental map of creating generic classes to kind of build up this, I don't know what the goal of it was. But I really like properties and methods. So I like object-oriented programming, but I don't like inheritance. And another thing I don't like about, typically don't like about object-oriented programming, is that it's difficult to manage dependencies. Yes, so for example, in Overmind, all the actions has access to all the state and the other actions and the effects. And that's something you don't really get out of the box doing like object-oriented programming in terms of writing classes. You would have to pass class instances down to each other. But with IOC, you get that. And you get a ton more with IOC. You get the testability and all this cool stuff. So that kind of solves that part. So if you have like more of a framework-based approach where you have these base classes, you don't do all this crazy inheritance. It's all about writing logic and state that is considered part of the same domain. And then you have the ability to just connect whatever dependency you need to these different classes, where it uses the IOC concept under the hood. I think it's insanely powerful. Because you get the best of both worlds. You get the isolation of a class, but you also get like the interdependency complexity for free. And everything's like, there's no question about the typing either. I reflected on this yesterday. What I also really like about classes is the typing. Like when you start doing functional and declarative programming, it's insanely difficult to do typing. But like typing, especially TypeScript, kind of came with the classes. It was built with these classes in mind. So there's like no question about like, should you do left side typing or right side typing for the primitives of the framework? You only have classes. So it's a given where you're supposed to do the typing. So I really like that as well. And the library, like the runtime library, it's 170 lines of code, and a lot of it is typing. So it's basically 100 lines of code. Then you have the dev tool, which is a couple of hundred lines of code. Also quite a bit of typing. And then the common is, just a constant. So that's also what I really like about this approach. Of course, this visual tool is way more code, but that's exactly how it should be. I think this is a much better approach to dealing with the complexities of state management, is having powerful visual tools where you rather have some very basic core concepts that allows you to express what you want. In this case, like class instances, and then blueprints for different types of class instances to handle different kinds of complexity. And then you have this like powerful visual mental, like this visual approach to understanding how everything is connected. Yeah, I guess that's what I wanted to share with you. And what I want to do, I'll be working on this over the weekend, so I'll get this state machine in here. And what we're going to try to do is to take our app that we currently built on Codesandbox, and we're going to like visually put it together here and code it, and see if we even run it. I'm not sure. Like, I think we'll continue on Codesandbox and do deployment there and still use Overmind for the actual application. But we should play around with it here so we kind of get this project moving, because it has some tiny quirks currently, and we just have to see how it actually feels, so that I can get it to a published state and like an alpha or something. And yeah, this is going to be like my third state management project. I just can't help myself. But I learn so much stuff all the time. And you're being exposed to different ways of doing things. Like IOC is such an uncommon thing to see in JavaScript, at least in my experience. And who knew that IOC was actually allowed to do this, what I've just been showing you here. That's the core ingredient that enabled all of this. Who could imagine that? It's something that you kind of have to move towards. And then all this stuff like looking into... oh, didn't it run? Oh, yeah. Anyways, so when we like open the inspector for the properties and stuff, that's all from Overmind. Like if I were going to build this again, I would kind of lost my enthusiasm. So it's like everything is kind of built on top of each other. And yeah, by the way, the actions, what you'll be able to do here is actually run an action. And since there's a static analyzer here already, we'll be able to actually like we know the number of arguments that you can pass to the thing. That's pretty cool. And we also know what argument, because there's a type fetcher API that describes the types for you. Even though you have like a custom type, we can figure out what is kind of the core of it. And then, but the point is that it will show a list of executions of that action. And then there will, of course, be like an overview where you see everything chronological. All the state changes and action executions is in kind of like a chronological order. And then, of course, we can do things like time travel and stuff. Again, I don't like see much benefit in the time travel itself. I see a benefit in seeing like what happens in the visual image. So for example, imagine having like a play button that moves very slowly, and then kind of the mental image kind of moves around to indicate to you, okay, something happened here, something happened here, something happened here. Like we can do tons of cool stuff with this. Super excited. Cool. I guess that's it. Yeah, and like a state machine here, it can have like its own color, for example. So you can see, oh, this is a state machine, and we can display other information here. We can highlight the current state, for example. So we can create a very specific visualization for state machines and whatever other classes that might come up to be beneficial. Anyways, I'm way over time here. But anyways, I hope you enjoyed it, and let me know if you just say you're excited about it. Just say it, because then I'm like, oh, people are excited about it, and then that motivates me to continue working on it. Okay, that's it for now. I'll talk to you tomorrow. No, not tomorrow, on Monday. See you then. Have a great weekend.